Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
Inspired by the growth of bones in the skeleton, researchers at the universities of Linköping in Sweden and Okayama in Japan have developed a combination of materials that can morph into various shapes before hardening. The material is initially soft, but later hardens through a bone development process that uses the same materials found in the skeleton. When we are born, we have gaps in our skulls that are covered by pieces of soft connective tissue called fontanelles. Now, researchers have combined materials which together resemble this natural process. We want to use this for applications where materials need to have different properties at different points in time. Firstly, the material is soft and flexible, and it is then locked into place when it hardens. This material could be used in, for example, complicated bone fractures. The idea was hatched during a research visit in Japan when materials scientist Edwin Jaeger met Hiroshi Kamioka and Emilio Hara, who conduct research into bones. The Japanese researchers had discovered a kind of biomolecule that could stimulate bone growth under a short period of time. Would it be possible to combine this biomolecule with Jaeger's materials research, to develop new materials with variable stiffness? In the study that followed, published in Advanced Materials, the researchers constructed a kind of simple, microrobot, one which can assume different shapes and change stiffness. The researchers began with a gel material called alginate. On one side of the gel, a polymer material is grown. This material is electroactive, and it changes its volume when a low voltage is applied, causing the microrobot to bend in a specified direction. On the other side of the gel, the researchers attached biomolecules that allow the soft gel material to harden. These biomolecules are extracted from the cell membrane of a kind of cell that is important for bone development. When the material is immersed in a cell culture medium, an environment that resembles the body and contains calcium and phosphor, the biomolecules make the gel mineralize and harden like bone. One potential application of interest to the researchers is bone healing. The idea is that the soft material, powered by the electroactive polymer, will be able to maneuver itself into spaces in complicated bone fractures and expand. When the material has then hardened, it can form the foundation for the construction of new bone. In their study, the researchers demonstrate that the material can wrap itself around chicken bones, and the artificial bone that subsequently develops grows together with the chicken bone. By making patterns in the gel, the researchers can determine how the simple microrobot will bend when voltage is applied. Perpendicular lines on the surface of the material make the robot bend in a semicircle, while diagonal lines make it bend like a corkscrew. By controlling how the material turns, we can make the microrobot move in different ways, and also affect how the material unfurls in broken bones. We can embed these movements into the material's structure, making complex programs for steering these robots unnecessary, says Edwin Jaeger. In order to learn more about the biocompatibility of this combination of materials, the researchers are now looking further into how its properties work together with living cells. The research was carried out with financial support from organizations including the Japanese Society for the Promotion of Science, JSPS, Bridge Fellowship Program and KAKENHI, the Swedish Research Council, Promobilia and Stint, Swedish Foundation for International Cooperation in Research and Higher. Materials provided by Linköping University. Original written by Karen Soderlund Leifler. Note: content may be edited for style and length. Dangfeng Cao, Jose G. Martinez, Emilio Satoshi Hara, Edwin W. H. Jaeger. 2022, January 17. Bone growth inspired, microrobots, that can create their own bone. Science Daily. Retrieved January 17, 2022 from ift.tt/3ij7ghn Linköping University. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.